Three different terms we are going to discuss. Before that, we should know what is called a gravitational field. Any region which surrounds a body where it experiences gravitational pull, any material body which experiences gravitational pull, that region we call it as gravitational field. Electric field is a region where electric influence can be felt. Magnet surrounding there exists a magnetic field. Magnetic region influence can be felt. So like that, any material body executing in a region where gravitational influence can be felt. We call it as gravitational field. Gravitational field intensity, gravitational potential energy, gravitational potential. Three factors are going to see. Gravitational field intensity. Expressed by E, force experienced per unit mass of a body. What is force? Newton's law of gravitation, G capital M small m by R square by small m, cancel. No sir, I am not calculating on the surface, I am calculating somewhere at a distance of R. No problem, we can put R square, small R square. So, Gm by R square. Sir, force by mass is called acceleration by Newton's second law. Yes, it is an acceleration. So, gravitational field intensity is nothing but an acceleration produced by a freely. It is not a falling body. Freely falling body means it becomes G. On the surface of the earth means it is replaced by G. That's all. Instead of small r, you put capital R means, then it is called freely falling body, small g. So this is acceleration produced by the body. A. Gravitational potential energy. Wherever you say the word energy or the potential energy, you call it as work done. Work done in moving a unit mass from the point to infinity. Work done in moving a unit mass from the point to infinity. When you go away from the earth, there exists a repulsion because attraction only, you are pushing away against the attractive force you are moving. So the work done in moving a unit mass from the point to infinity, we call it as gravitational potential. Work done in moving a mass from the point to infinity is gravitational potential energy. Gravitational potential energy. V, gravitational potential. V represented by U, gravitational potential energy. Work done in moving a unit mass. Work done is force into displacement. F into dx. Gmm by x square into dx. R means you can put dr. This is small work done. Total work done means we have to integrate the equation. From where to where you are moving? You are moving from the point to infinity or to infinity. From the surface, I am moving, sir. Capital R to infinity. That's all. Simplify, you will get the answer minus Gm by R. Gravitational potential. Work done in moving a unit mass of 1 kilogram from the point to infinity. Work done in moving a mass, it is not unit mass, it is not 1 kilogram. You have got some mass. Same formula into 1 you are putting because mass is 1 kilogram. Here it is not 1, it is M. Same formula. 1 kilogram means potential, M kilogram means potential. Correct? Gravitational field, gravitational potential, gravitational field intensity, gravitational potential energy. All small topics, basic information. Next, escape velocity. VE, here, capital M mass, radius R. This is infinity. Any point outside the gravitational field, we call it as infinity. That's all. Infinite distance. Infinity means electric field, electric potential. Same concept. Where you have a charge Q, surrounding there exists electric field. Beyond any point outside that one, we call it as infinity. So that particular electric field. Yeah. Similarly, this is gravitational field region. Beyond that region, any point is infinity. Point P, point Q. This distance is x. This distance is dx. Kinetic energy of the particle or a body of mass is half m ve square. Ve is nothing but escape speed or escape velocity. Gravitational potential energy. Just now we have seen the formula, ma. Gravitational potential energy minus Gmm by R. Sir, you have put x here, sir. We can put x. No problem. Minus Gmm by R. Surface of the earth means it will become capital. But you are moving away. Small r only that. So, the work done by the body in moving from one point to another point, we call it as kinetic energy, which changes into potential energy at infinity. So, the kinetic energy half mv square is equal to Gmm by R, the potential. You are moving against. Already one negative sign is there. Against means one more negative sign. You can derive using integration method. What we have discussed before, you can derive this value. Gmm by R. No, sir. I am moving from the surface to outside. Beyond the gravitational field. From here to here, I am moving. So integration limit is capital R to infinity only out of in our derivation for gravitational potential energy, small r to infinity we have put. We are moving from the surface of the earth. So capital R. Here also capital R. Cancel. V square is 2 gm by R. But G is equal to gm by R square. Gm is equal to gr square. Implies V square is equal to 2 into gr square by R. Cancel. V root of 2gr. This is the expression for escape velocity. The minimum velocity necessary for a body to escape outside the gravitational field. You substitute the value of G as 9.8. You substitute the value of R 6,400 kilometers. You can substitute. V is equal to root of 2 into 9.8 into R 6,400 kilometers 10 power 3. We are rearranging this 2 into multiply 1 0 here. It will become 98, 64, 1 0 you multiply. So this 1 0, this 10 power 3 will become 10 power 4. 98 I get as 2 into 49 into 64 into 10 power 4. So V is equal to root of 2 into 2, 2, root of 49, 7, root of 64, 8, 10 power 4, root is 10 power 2. 56 into 2, 112 into 10 power 2, 11.2 into 10 power 3 meters per second, 11.2 kilometers per second. So, the escape velocity or escape speed is the velocity in which the body moves away from the surface of the earth with a speed of 11.2 kilometers. Any speed or any velocity less than this one, the body will come down. If you want to project the body to escape outside the gravitational field, you should project with a velocity of 11.2 kilometers. Okay, next. Orbital velocity. V naught. Yes, radius capital R, mass capital M. Here one body is revolving at a height h. V naught is the orbital, it is orbiting around the earth. Satellite. Okay, V naught. Two formulas. One is called force by Newton's second law. Newton's law of gravitation, Gmm by R square. In our case, R plus h the whole square. From the center to this point, the distance is R plus h. Another one, any body moving in circular path will experience a centripetal force. Mv square by R. M v square by r. M v square by r is nothing but r plus h. From the center to this point, this is r, so r plus. Both are attractive force equate. M v naught square by r plus h is equal to g mm by r plus h the whole square. M cancel, 1 r plus h cancels, v naught square is gm. That is gr square. By r plus h. So, what will you get? V naught square is equal to gr square. Body is moving close to the surface of the earth. Gr square by r plus h. Body is moving close to the surface of the earth. Means h is approximately 0. Satellite moving around the earth, 1,000 kilometers, 2,000 kilometers, because this itself is 6,400 kilometers. Compared to R, H is small, that's all. H is not very small. R is 6,400 kilometers. Compared to that, H is small. So we are neglecting. GR square by R. Cancel. V naught is root of G naught. So this is orbital velocity. Escape velocity root of 2gr we wrote. So you can relate these two. What? V is equal to root of 2 into root of gr. Root of 2 into root gr. Root gr is nothing but VO. So I can write orbital velocity into root 2 is escape velocity. Escape velocity is root 2 times orbital. Okay, Mama? Simple. Next. Total energy of an orbiting satellite. Kinetic energy EK half m v naught square. Half m v naught is nothing but, before approximating I am writing v naught square. So gm by r plus h. So gmm by 2 into r plus h. This is kinetic energy. Potential energy minus gmm by r, that is minus gmm by r plus h. Therefore, total energy E or U, anything you can take, U only I will take that. Okay, you take. EK gmm by 2 into r plus h minus gmm by r. Gmm by r plus h is common. Take it out. Half minus 1 minus half. So you are getting minus gmm by 2 into r plus h. This is the expression for total energy. Nearer to the surface of the earth, h can be neglected. Minus gmm by 2 r. Total energy of a orbiting satellite. Okay. Kepler's laws of planetary motion. Kepler's laws. Geocentric theory, heliocentric theory. Geocentric, keeping Earth stationary. All the planets and the sun revolving around the Earth, given by Ptolemy, one scientist. That was totally wrong. Then comes Nicholas Copernicus. He argued that Earth, along with other planets, moving around the sun in circular orbit. But the distance of the Earth from the sun is not the same throughout. That means the radius is not a constant. Radius is not a constant means it is not moving in circular orbit. It is moving in elliptical orbit. So elliptical orbit means what is the equation? That is called Kepler's laws. Law of orbit. Sun. Planet is revolving around the sun. Closer distance of the planet, that position we call it as perigee. Farther distance of the planet from the sun, we call it as apogee. The path of each planet moving around the sun is an ellipse. That is called law of orbit. Path of each planet revolving around the sun is elliptical orbit. It is an ellipse. First law. Second, law of areas. Sun, perigee position, apogee position. BC you take MNO. The radius vector sweeps out or covers unequal areas in equal intervals of time. The radius vector sweeps unequal areas in equal intervals of time. We have to explain. Planet is moving, say, assume in clockwise direction. B to C, it moves. Here it is moving N to M. Planetary motion. The law says B to C, the planet moving distance, moving velocity is the same N to M. Sir, here the distance is less, here the distance is more. How it is possible? Simple. Here it should move faster. Here it should move slower. That's all. You are standing here, man. Here 1 meter distance, sir. Here 5 meter distance. I have to cover both the distance in 5 seconds. Five-second time is fixed. Here 1 meter, here 5 meters. So here I should move slower 5 seconds. Here I should move faster. So speed is more. That means velocity near perigee position is more than the velocity near apogee position. So Vp, velocity in perigee, is greater than Va. Covering unequal distance and equal intervals of time. So velocity should be different. It is different here. Perigee position, the velocity is more. Apogee position, it is not here alone. B to C distance and N to M distance, the velocity is less near the approach. And third law of periods. What is called a period, first of all? Time taken by the planet to revolve around the sun once. That is called time period. Simple pendulum oscillation we have discussed. You are calculating time for 10 oscillations. 14 seconds. Period is 14 by 10, 1.4. Time taken for one oscillation. Here, time taken for one revolution. Square of the orbital period is proportional to cube of the mean distance between the sun and the planet. You cannot write capital R, no more capital R here, because elliptical orbit. Semi-major axis, semi-minor axis distance, average value is small r. Square of the orbital period is proportional to cube of the mean distance between the planet and the sun. Sir, Mercury is very, very closer. Pluto is very much far away. Then how come it is possible? T square is equal to K R cube. T square by R cube is equal to K. Constant. Any planet you take, substitute time period T square, substitute mean distance from the center of the planet to the sun. The ratio T square by R cube is constant. It is not T square alone or R cube alone, you should compare. The ratio T square by R cube is a constant. That is called law of periods. So this is Kepler's laws of planetary motion. So these are the basic topics in gravitation. We have discussed so far gravitational field intensity, gravitational potential. Before that, Newton's law of gravitation, basic information we have done. Then acceleration due to gravity is not a constant, it is varying. Variation of acceleration due to gravity, g with altitude, latitude, depth we have considered. Then the very famous two questions, escape velocity and orbital velocity. VE, escape velocity, root of 2gr. Orbital velocity, root of gr. We have derived. Then your Kepler's laws of planetary motion. There we have three laws: law of orbit, law of areas, law of periods. Okay. Thank you.